Okay, so as I'm working on it on the Octave for Babies, I wanted to add um, a new content. It's going to be something like the very first steps for signal processing. Um, and I'm seeing the Octave for Babies as a opportunity for this. Um, and on this video, we will try something very basic, very simple, very easy to understand, something that you saw on your high school days, which is square functions. And we will just do a scratch of a function, and also we will use the Octave for plot. So it's going to be something very easy, uh, a very easy function, f of x, which is equal x squared. So this is very easy to plot. We don't need any tool to plot this. We can do by hand. Right here, in order to do a scratch of this function, we can just attribute values to this function. And for do a scratch, do a draw of this function, trying to represent the whole function, uh, is good if we attribute values, trying to get um, the most points, trying to cover the most point that we can, so we can attribute since negative values passing to 0 and going to a positive value. And as this square function um, is one of the most is the function that we see with more often. We know that is a symmetric function. We can mirror the function. So if we attribute negative values like from -3 passing to 0, then 1, 2, and 3, very easy. And right here, f of x is y. So -3 square, which is equal 9, and -2 square, which is equal 4, and -1 is equal 1. Right here 0, 1 square is equal 1, 2 square is equal 4, and 3 square is equal 9. Very easy. And now we can try to do a scratch of this function. It's nothing sophisticated. It's just like I said, at least for me, is kind of a intro to signal processing. We will not see nothing sophisticated in program language, and also if you don't have acquired Octave for Babies, is available for free, and there you'll find how you can install the Octave, and the Octave is the option if you don't have access to the MATLAB. But MATLAB, you can have it for free also. 1 month trial license. But Octave, my goal with the Octave it was to build graphical user interfaces, uh, try to pass to you how you can build these graphical user interfaces, the step by step how you can beginning with the Octave, and right here you can find how you can start the first steps with Octave, basic code, first steps with UI elements, user interface elements. So if you're attempting to this area, to this field of graphical user interfaces, signal processing is a option for you. And let's keep going right here. So we need now to name this, pass these values for to this axis. So -1, -2, -3, -2, -1, 1, 2, and 3. And this is will get out of scale, but it still works for illustrate this function. So for x equal -3, let's see, 1, 2, 3, 4, 5, 6, 7. Yeah, is a bit out of scale, very out of scale. 2, 3, 4, 5, 6, 7, 8, 9. And for -2 is equal 4. 1, 2, 3, 4. Okay. Again, nothing sophisticated, very easy. You saw this on your high school days. For 1 is equal 1. And right here, we are just trying to learn how to do it with the Octave, because it can be the intro for signal processing, since this area it requires a good knowledge in functions. And again, right here is just mirror. This function is mirrored. And also, since my goal with the Octave for Babies is to give to you a sense on how to build graphical user interfaces, we can build since the most simple one to the most complex one, since we got more deeply on our knowledge of functions, but also it will requires from you a very good knowledge on program language, and also on the resources from the Octave. And right here, you just need to mirror the function. Okay, very easy. Just a scratch. And now we can see how we can do with the octave. First of all, like we have done right here on this scratch, we need to specify the x-axis. So in order to try to get a symmetric function, we will specify since um, like minus 10 to 10, nothing like minus 10 to 5 or minus 5 to 2, because this way we are not covering the whole axis symmetrically. So we can pass x min is just a variable that we are naming, and minus 10, and x maximum, again just a variable that we are naming, and storing on this variable the value that um, we wanted that our axis to have. And now we use this comment line space. We are now passing the arguments of our axis to this to this function line space. So line space will draw the x-axis. So line space x min, x max, and again, as this function line space is drawing the x-axis, we need also to pass the number of points that this axis will be covering, and the maximum pointing that will pass more precisely this function can be plotted, illustrated visually. And now let me comment this is a function f of x. So it is f of x, and now the function itself, we will call this x, y, sorry, we'll call y, and y is equal x squared. And now we need to plot this function. You can run it. We can run it, but we are not asking the Octave to plot nothing. Now we need to ask to plot. So we will plot the x-axis and now the function. In the function, as you can see right here, it receives the y is a function of x. So increases as axis increase. Okay, now let me see. I think right here. I'm missing this comma right here. Okay, let's try. Oh, forgive me. Right here is minus 10. Of course, we're not plotting anything because it's on the same value of the axis. Okay, right now, I think it will work. Exactly. Okay. Very simple, just the basics, and it's all that I wanted to pass to you on this video. Um, that's it. Thank you. Bye bye.